Okay, I think it's time to start. First, of course, the usual reminder. This is my phone. It's not green. I wish it was, but if you have a phone, please make it silent. Okay, this talk is deployment of Qt applications. My name is Harald Ferninger. I'm currently release manager of Qt since a few months. This is a picture of me before I was release manager, and this is the after. No, just kidding. I like my job. So as release manager, I'm, of course, quite motivated to get releases out to you, which leads us to the next point. How do you release to your customers? How do you make the binaries? How do you ship stuff to your customers? We usually only give you a source code package unless you're on Windows or on Mac. So how do you get this stuff out? And that will be topic of this talk. First, the contents. Since Qt is a platform-independent toolkit, of course, there are a lot of platform-independent issues attached to it, which we're going to handle first. Then we're going to dive into the operating system specifics, take a look at Windows, take a look at Mac OS X, take a look at GNU/Linux, and several other Unixes. And the last chapter is called Tweaks, because that's where I dumped everything I couldn't dump anywhere else. Now for the non-contents. We will not talk about graphical installers or installer builders or something like that. This would be a bit out of scope for this talk. We have some solutions. For example, our partners Bitrock, they offer a platform-independent installer with a nice scripting language where you can install things and have some user interaction, like asking for his registration number and all that stuff. But this, unfortunately, is not content of this talk. Instead, we're focusing on getting a Qt binary out. So the end of my talk will be, at the end of my talk, I want you to be able to have a binary which you can put in a zip file or an a.tar.gz and send to your customer. And if you want to have an installer or something, they're usually quite self-explaining, and there's a lot of documentation on the market, so I suppose you can figure it out yourself how you can get this binary into a nice graphical GUI installer with all the flashy animations. The second of the things I'm not going to talk about is build systems. I'm assuming we're all sensible people and using qmake. Who is not using qmake? Okay, 1/3 of the audience already against me. No, of course I'm going to explain. I'm trying to explain concepts here. So and give the example based on qmake. So if you use any other build system, you just have to tell your build system how to do these things. So I try to keep it as generic as possible, but of course the examples here are always qmake. So who of you is a release manager? One, two, ooh, a lot. Wow, I share your pain. No. Who of you deploys to more than one platform? That's over 1/3. Who of you deploys to more than 2 platforms? Wow, the same people, almost. Okay, good. Then you're on the right track. Let's see. First we're going to, can you read this? Okay, first we talk about platform-independent issues. And under the platform-independent issues, I listed 3 points. First, you have to decide whether you want to have a static library or a shared library. I'm going to talk a little bit about the differences, about the advantages, about the disadvantages of using static or shared libraries, and we're going to look at plugins and resources, which are usually these tiny little things you usually forget to deploy, and then on your customer machine nothing works. So shared versus static linking, I suppose most of you are familiar with that concept. We can either link statically, that's the picture on the left side, meaning that we will combine Qt and your application in one big binary. It's all going to be one big interwoven blob. The compiler is not distinguishing between Qt code, not application code. That code will be totally merged, separated. There's no separation anymore. It's just one big blob of binary at the end of the day if you link Qt statically. As opposed to a link to a shared library, there we have a very clear separation. We have Qt here in the middle, which is our library. It's one binary, completely separated. Hey, I have a laser pointer. And then you have here 3 applications which link to that Qt library. And in those applications, there's only application code, and here's only Qt code. It's a complete separate entity. It's a different file on the file system. And here, those little P's are plugins. So those guys can, of course, link to Qt too. And here you already see one disadvantage of static linking. There are no plugins here, only here. So how do we build a static library? Easy. You unpack Qt. And I would suggest you unpack it as a new user on a fresh machine, fresh install, or maybe use a virtual machine in a VMware or a Xen or so to make sure you don't have any artifacts in your environment around. Unpack the Qt as you get it from us, and configure it with -static. That will automatically give you a static library in release mode. And this is the safe bet here to create one. And then you build the source subdirectory. And please only build the source subdirectory. Because if you build everything, you will build all the examples and designer and assistant and linguist, and everything will statically link Qt, meaning that you probably have 3 or 4 gigabytes in your hard drive, just huge applications. So usually I suggest just building the source subdirectory because static you usually only build when you want to deploy things. While you develop things, you don't develop with a static library because your linking time will just forever because you have to generate every time you relink, you have to generate this huge blob of data and the compiler will crunch through quite a lot of code. So -static in a clean directory, build this source subdirectory and bam, you have a static library. To the advantages, if you link your application static, you remember you get one big blob of data. You have one single executable. You don't have to worry about shipping this Qt library and this application. You don't have to worry that they will be split up, that someone has only the Qt library and the other guy only has the application and then nothing works. You have one nice little big binary which you can execute directly from the internet with an unsafe browser. The user just says, yeah, sure, open, bam, it works. And yes, no partial unusable installations. Like I usually had the cases that people take my application and drag it on their desktop. What they didn't realize was they dragged actually the executable and didn't create a link on it. So suddenly they had the executable on the desktop and the library was still in the old folder and it didn't work. Yeah, so it's freely relocatable. Users can drag and drop it anywhere. Doesn't matter. What you also get is much better compiler optimizations, because as I said, it's one big blob of data. There's no one else who will possibly interface with that code and use symbols from it and so on. You get one blob of data. So the compilers do something which is called inter-process optimizations or intermodule optimizations. They can just they can realize, okay, this part of Qt is not used. I'm not linking it into the library. Or, hey, this part of Qt is used very often. I'll just inline the call. Because there is no external call going into a separate library. It can just really, really aggressively inline things and optimize better. Of course, we have the usual disadvantages. We have huge executable, because every executable has to have the Qt library in there plus your application code. You'll get big patches if you change a few lines of code. Since the compiler does all these optimizations, it can happen to you that changing a few lines of code will produce a quite different binary. So if you just have a diff between 2 binaries, even that diff will be huge. You are unable to load Qt plugins, because plugins are dynamic libraries which are loaded at runtime. And of course, there's no Qt library to which they can link. So you cannot, at a later process, just say, yep, load that plugin and use some Qt symbols. That doesn't work. And linking to other Qt-based libraries is problematic. Let's say you have a third-party component somewhere which internally is using Qt, and your application is using Qt too, but has it statically linked. You suddenly have Qt twice in memory. You have duplicate symbols, and not so nice things might happen depending on your operating system. And of course, you build Qt static, everything seems to work well, then finally you link your application, and then you panic because your compiler shouts at you, I have unresolved symbols. That can happen very easily because a static library is just a bunch of object files. It's not something complete. It's not a DLL or shared object. It's just really a bunch of object files in one file. It doesn't have a concept of linking to external libraries or dependencies or anything. It's just object files. And Qt internally uses, of course, some symbols from platform-specific libraries. Like on X11, we use Xrender. On macOS, we use Carbon. And probably some other libraries. If you compile with SQL support, MySQL support, then of course we need symbols from the MySQL client library and all that. And if you link Qt statically, you will never see that because in static libraries, there is no such thing as unresolved symbol because it's just a bunch of object files. So you have to make sure that your application, your own application, links to each and every library that Qt actually uses. So you have to figure out if you get unresolved symbols, where are they from? I have to link to that too. If you use qmake, then qmake does it automatically because qmake knows what Qt links to and adds it. If you use another build system, you have to tell your build system. And as I mentioned, you cannot have plugins. So all the plugins have to be linked statically in this big blob of code. And to do that in Qt, you configure with Qt and then the type of plugin you want and the specific plugin from that type. So for example, minus qt-sql-mysql. Instead of Qt plugin MySQL, you have to use qt-sql-mysql to actually link it into the library, or qt-decoration-plastique. That will compile the plastique code, that will compile the MySQL code, add it to the static Qt library, and then you can use it later. If you build those guys as a plugin, you cannot use it later. Okay, so much for the static libraries. If you still have questions, I take it at the end. Let's look at shared libraries. First of all, I want to give you a little bit of background. I hope I won't bore you too much. Background about shared library, it helped me a lot to understand these concepts. So here I have a library or an application. What is it? It's one file containing a lot of code and, depending on the type, some data. It's one file, code, and data. For an application, when you say it's an application, an executable, what happens is if you load it, the operating system will look for a symbol called main, which is your entry point. This symbol main will point somewhere into your code, let's say here, and then it starts executing. Code, 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 execute, execute. You have a branch, you jump here, code, 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 code. You read some data, and so on. For a library, of course, it's completely different. A library is still a lot of code. Code, 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 and some data. But you have a symbol table attached, which actually has a lot of symbols. So we have update, which points here, intersects, which points here, and so on. So in a library, you have a lot of entry points, which all have a name. So basically what you're doing when you pay for your Qt license, all you get is a lot of code and some names. That's it. The rest is just syntactical sugar for the C++ compiler. Now, let's look at Qt specific. This I'm just going to brag about a little bit about Qt. I just built Qt on a normal Ubuntu box for i386 with a GCC and of course the X11 edition. What you get if you build libqt GUI, you get a code segment of 4.6 megabyte. So that is just plain code. Then you get read-only data of around 500 kilobyte. Those are usually small icons and all the strings that are in there and all the other stuff. You get some read-write data, 5 kilobyte, and the init code segment of 23 byte. The init code segment is the code that has to be executed when you load the library into memory. The good thing is that the code and the read-only data are shared between processes. So those 4.6 megabyte and those 500 kilobytes have to be in memory only once. If you have 10 Qt applications, you have these two guys in memory only once, because every Qt application shares that data. The read-write data and the init code segments are tiny. I mean, it's 5 kilobyte and 23. These two guys you have to duplicate for each and every application you load into memory, and they're really small. So on a modern system, it's absolutely insignificant, which gives you quite a fast application startup. Okay, that was just to brag how great Qt is, because we put a lot of effort into Qt 4.0 to actually keep those segments as small as possible. Now, how do we deal with shared libraries? If you have an application and you link to shared libraries, all your dependent libraries must be in the operating system's library search path. Otherwise, your operating system won't launch your application. So everything you link to when the user double clicks or when the user executes your binary, these libraries all have to be in the shared path. Now comes the bad part of it. The search path differs between platforms. On Windows, I copied that from the MSDN. First, the operating system looks in the directory of the executable, then the current working directory, then the Windows system directory, then the Windows directory, then every directory in the path. And then if that DLL cannot be found, it will panic out. It will simply refuse to load your application. On Unixes, you have the LD library path, except on Mac where they call it a DYLD library path, which is an environment variable you can set, like the path variable where the dynamic link loader will look for libraries. And you also have some built-in path, and usually it's on Linux system, it's etc.ld.so.conf, where we have a few paths where the linker will look by default for libraries. So what does that mean for us? If you have a shared library, if you have Qt as a shared library, you have to make sure that it's in one of these directories, otherwise your application won't launch. Sorry. So what I'm going to tell you in the platform-dependent part is one cookbook, one recipe of how to most conveniently install Qt. So I won't bore you with all the details where else you can put the library, but I give you one recipe where I say this makes sense, do it like this, and then you won't rush into trouble. And if you want to divert from that path, if you say, but I want to install Qt into some other directory, then yes, you have to go through all this and make sure that the operating system can find it. So the shared linking advantages are, of course, you get smaller executables because you have one Qt library and let's say you have 3 applications that use Qt, they will be considerably smaller. You get faster load times for other Qt applications because once the Qt library is in memory, all the other applications will just link to it and it doesn't have to be loaded into the main system's memory again, except for those 23 bytes, which we can ignore. Loading plugins in Qt-based shared libraries are possible, so you can link to Qt-based shared libraries, you can load plugins. Of course, your updates and patches will be quite small because you only patch your actual binary, or you can swap out just the Qt library and so on and don't have to ship a complete new binary. The disadvantages here, you get an additional symbol resolve step on load. So when you load your application, if you remember, we have the symbol table. So for every symbol you use in Qt, it has to first, the operating system first has to look it up and say, where is it? Could be in Qt GUI. No, maybe it's in Qt Core. There it is. Okay, tie. The overhead was bad on old Linux systems. In the meantime, on modern Linux system, you have something called pre-linking. So a lot of these steps can be done once while installing the operating system, and then you never have to do this, or then this step gets a lot quicker. And also on Windows, it's also quite quick, so the load-up times are reasonable. And the other disadvantage is, of course, you have more files to deploy. So much for static and shared libraries. Let's take a look at plugins and resources. What is a resource? A resource is plain read-only data of any type. It can be text, can be images, sounds, multimedia stuff, whatever you like. For us, a resource is just data. So nothing you can actually execute, but just data. Now, resources can be statically compiled into an executable. So, for example, the typical example is the application icon, which is statically linked into your application executable, and then you can use it from there. And since Qt 4.2, we can also load resources at runtime. What does that mean? They can be shared between processes. Let's say you have a big company logo and 32-bit color, 1024 times 786, and you have 10 applications that want to display this. You make it a shared resource and reload it at runtime, so this thing is in memory only once, although 10 applications are actually using it. And it's important, it's read-only data, so that can be shared between instances, it can be shared between all applications that use it. As I mentioned, the application icon is the resource that is statically compiled into an application. So, of course, you can ship it as an external PNG too, but why would you? You can link it to the application. Usually only your application uses your application icon, no one else. Once you have it as a resource, you can use QWidget : setWindowIcon, sorry, typo. setWindowIcon to set the application icon at runtime. So when you double-click your application and you minimize it, it will have the right icon, and do things. If you use Alt-Tab and so on, the windowing system will show the right icon for your application. That's the good news. The bad news is that we have something, that we have the icon which the operating system will use to display your application in, let's say, the file manager and in the Finder on Mac OS X, or on the Windows Internet Explorer, or in the Start menu, and so on. And the operating system has to find this icon before your application is actually running. That thing can be set at runtime. That's easy. Because your application already runs, you set it, the operating system knows it. But this guy has to exist before your application is actually executed, so that the right icon is showed. And I will show you in the platform dependent parts where you can set this and how you can tie your icon to your application so that the operating system actually knows how to display your application, how to display the right icon for your application. So much for resources. Let's look at plugins. Plugins are shared libraries that are dynamically opened at runtime by the application. So remember, we had the qt-dll, which you link to. This guy has to exist when the operating system is actually opening your binary, when the operating system is loading your binary. Plugins don't have to exist at that time. They are loaded later. So at some point, the application is running for 3 days, then the user decides to open a JPEG image. We look through all the image plugin, load the JPEG code dynamically into memory, and you will have a JPEG encoder. If the user never opens a JPEG encoder, that code will never ever be in memory. So the plugins don't have to be in the system's library search path. Instead, they have to be somewhere where Qt can find it. So where was that thing again? Again, Qt provides reasonable defaults. On Unix-like systems, you can use the plugins subdirectory of your installation prefix. Usually you install into somewhere like /opt/mysoftware, and then you just add a plugins subdirectory there and dump all your plugins in there, and Qt will find them. And on all systems, including Unix systems, of course, so Unix and Windows and Mac OS, it will look into the plugin subdirectory relative to the executable. So wherever your executable is, if there's a plugin subdirectory in that folder, it will actually use those plugins. And of course, there are a lot of ways to override that. You can set the Qt plugin path environment variable. You can write a qt.conf configuration file in the directory of your executable. So Qt will open that qt.conf file, and you can check the documentation. It's like an ini file style. You just write which plugins it should load or where to look for plugins. And you have some API calls, so you can actually set it at runtime. You can set Q application set library path or Q resource add search path for shared resources. So multiple ways, and I think with that we cover pretty much all cases. Let's say you have an installer, you install your plugin somewhere, you write an entry in the registry. At runtime, you read that entry from the registry, and you use the set library path to set it, to tell Qt where to look for. Or you just have an embedded environment, you install Qt into /userlib and write a qt-conf to look for your plugins in wherever. And third-party people can third-party installations can check that qt-conf and add their own plugins to it. Or you just say, I have a Qt plugin path environment variable. You make a small wrapper shell script, set that thing, and Qt will find the plugins. And again, in the platform-specific parts, I will show you where I would usually install the plugins. And this is just for information if you want to deviate from the way that I show you. So much for the platform-independent parts. Let's look at the operating system specifics. We start with Windows. Go over to Mac OS, GNU/Linux, and then other Unixes. This, I would say, is the typical Qt application, how I saw it a lot of time, or how I saw a lot of deployments from. You have the-app.exe, which is your executable. You have Qt core 4.dll, which is the Qt core library, Qt GUI 4.dll, Qt GUI library, in the same directory as the binary. So it will be resolved by default. You don't have to worry. Then a plugin subfolder with your plugin 1.dll and plugin 2.dll. Of course, if you need the SQL module, you can install qt-sql 4.dll and whatever else. So if you stick to this pattern, you should be quite safe. A speciality of Windows is it's one of the few operating systems. It doesn't come with the... Okay, I will not say negative things now. It's not the Visual C runtime, the C and the C++ runtime is not installed by default, or you cannot rely that it's installed by default. So what you have to do is to make sure that your compiler's C runtime and C++ runtime is installed. Otherwise, your application won't load. The good thing is that if you use Microsoft Visual C++, they ship a redistributable version of msvcr whatever.dll and msvcp whatever.dll. And the msvcp, the C++ runtime, you only need when you actually have STL support on. Otherwise, if you don't use anything from the standard C++ runtime, you don't need it. So Microsoft already has in the, where is it? If you install it, there's a underscore redistributable folder, and then there's a redistributable version of those guys. So in your install step, you just call them, and they will do the right thing. So they will check whether there's a newer version already. They will replace it. If it's an older version, they will do nothing, and so on. So usually, you don't have to worry about the C runtime if you use the Microsoft tools. If you use MinGW on Windows, the GCC free compiler, you need to install MinGW m10.dll, which is the MinGW runtime. And that I would suggest you just ship with your, you just install into the same directory as your binary. So don't try to be clever and install it into Windows System 32 and so on, because then you get into the usual DLL hell. Yeah, I already mentioned the DLL hell. You probably are all aware of it. It's a nice long Wikipedia article even on it. Basically, it means that if you have multiple versions of the same library, then you might have trouble. You will link to the wrong ones. You will load the wrong ones. You will have two different versions of the same library load into memory. And very interesting things will happen, which you probably don't want to happen. So roughly 15 years after introducing the DLL hell, Microsoft has the solution for it, which is called Manifest. It was introduced with Visual Studio 2005 and requires Windows XP, Service Pack 2, as far as I know, or Windows Vista. What is a manifest? A manifest is basically just a file saying, I use this runtime of this version. So you can define which kind of library it will load. So even if there's a different library and the library search path and so on, Windows will ignore that and will actually use that library that you require. So you can make sure that you actually link to the right C runtime, that you don't mix a debug C runtime with a release C runtime, because that's the very, very, very common case of having crashes. Since you're mixing two runtimes, that's not good. Qt, again, makes it easy, because the manifest support is enabled by default. Or you can force it to be enabled by saying config + equals embed manifest exe. So if you use qmake, it will automatically generate manifest files. which will tell the linker which libc Qt uses. And of course, your application has to use the same libc as Qt uses, otherwise you'll get this mix-up. So your application will refuse to load the wrong libc. We will expand this further in Qt 4.3, and when Vista is actually out, so you can have a bit cleverer support, like if you have other third-party libraries, a MySQL library, and so on, that you can mix it. If you are interested in that, there's quite some extensive coverage in the MSDN explaining manifests. And the default that we use basically defines which version of libc is used. Okay, so much for Windows. Let's look at Mac OS X. That's a typical Qt app. I'll give you some time to read it all. Of course, it's tiny. Mac OS has something called bundle, application bundles. So what is an application bundle? Application bundle is just a normal directory. Usually it's called directory name .app, so it has the .app suffix, but that's not strictly required. It's just a convention. That that directory contains all the executables, all the resources, all the plugins, and all the dependent libraries. So if you read the Mac OS X documentation, they show you where to copy that stuff in. And they basically do it by convention. There's a property list in this directory which defines what is in there. And so basically you put everything in one directory in certain paths. And Mac OS X will detect that it is actually a bundle and treat it just like a single application or document. I have a screenshot here. Here, for example, you have assistant, designer, linguist, Qt demo, and you see this is the Mac OS X Finder, and it just looks like any other binary, although it's in reality a directory called designer.app with a property list in here, with the actual binary, with the application icon, and with some more information about it. So this is how a subdirectory would usually look like, and this is how Mac shows the bundles. So the user has quite difficulties destroying this application. Of course, if he uses shell and does the wrong thing, he can do it. But from Finder, you just take this designer, you drop it somewhere, you always copy the whole hierarchy. You copy all the libraries, all the plugins, everything will always be together in one place. And you don't have to worry that you get half installations. So how do we bundle a bundle? qmake will create bundles by default. So if you just compile your Hello World application, you'll already get it in a bundle. It will create helloworld.app with the right infrastructure, with the property list, with all that stuff. So so usually the question is, okay, I built my application, how do I execute it? Because all I get is this funny subdirectory. What is it? Of course, you have to either double-click on it in Finder, or you have to use the open command. You say open this directory, and then macOS will find out where the binary is, set all the environment, and load it. So how do we get Qt in there? Because by default, if you build something, you will just have a subdirectory with your binary. And you can use the install name tool, which is shipped with the macOS X SDK, to tie the Qt libraries and the Qt plugins to your bundle. I omitted all the command line arguments to install name tools, because if you read the deployment documentation at drjoltek.com, or if you open Assistant, if you read the Qt documentation, we have a quite extensive documentation how to actually copy Qt, where to copy Qt in there, and then tell the bundle that Qt is inside of this bundle, use this Qt version from that bundle. So once you copied the Qt libraries or your plugins or your resources into that .app folder, you have one folder, and this is your application. You can create a compressed disk image, which is basically just like an ISO file. It is a small file which contains internally a file system which you can compress. You can create those guys from the macOS X disk utility. You can create this compressed disk image. Again, I don't have examples. There are a lot of examples on the web out there. And the users can just download it. It has the extension DMG usually. What happens is the macOS will mount it just like a CD-ROM or just like any other file system. It will mount it. You will see it in the drive section. You will see this new drive, which is your application, and inside is your one bundle. So all your users have to do is to take this bundle and drag it somewhere, either on their desktop or in their application folder, or it doesn't matter. They drag and drop it, and that's all the installation that is required. So here I have a Qt4 application, which is actually out there on the market and uses this this concept. It is called Vengo Phone. I downloaded it from the web. I double-click the DMG file, and what happens is it's automatically mounted. After, of course, the security paranoia check whether I really want to mount it, you get it as a new drive. Here they only have one application icon, which is called Vengo Phone. And the users can take this, your users can take this guy and drag it into the applications folder, and then it's installed. Or they can take it and drag it on their desktop, or take it and drag it in their taskbar, or whatever they want. So you always get this nice little complete installation archive. There's another concept called universal binaries. On the Mac, as you might have heard, macOS or Apple switched to Intel. Is that an Intel PowerBook there in the first row? Okay, so you get if you buy a MacBook, or these guys, the silver ones, you either get them with a PowerPC or an Intel. And Apple wants to make it as easy as possible for the users to transit from PowerPC-based hardware to Intel hardware. So what they introduced is something called a universal binary, which runs on multiple architecture. What it really is it's just you compile two versions. In their SDK, they have a cross-compiler. So every time you compile your application, you compile two versions of it, one for i386 and one for PPC. And in the end, it's just copied together, meaning that every library and every binary is twice the size than before. So double the installation size, but hey, bandwidth is free or is cheap nowadays. And what you get is, you can configure Qt with -universal to enable multiple arc binaries. So if you configure with universal, you get a twice as fat Qt library containing two architectures. And if you run the file command on it, you will get the app is a Mac O fat file. They call it sometimes fat, sometimes universal, with two architectures. You have the application for, I think the battery is low, for architecture PowerPC, and you have the application for architecture i386. And at runtime, if the user double-clicks it, if I double-click it on a PowerPC, it will execute the PowerPC section. If someone double-clicks it on a newer PowerBook, it will execute the i386 section. But that is completely transparent for you. Good news is Qt supports that. You just configure with -universal, and if you run qmake, you will actually do the right thing. If you use any other build system, tell it to use universal. And of course, everything you link to, if you link to the MySQL library, if you link to ODB, if you link to anything, that has to be universal as well. Now, how do we get the application icon? You let your artist create, okay, this thing is empty. You let your artist create a ICNS file, which is the native Mac icon file. There's an icon editor on the Mac, so it's quite easy to use. And all you need to do is to add it to your project. If you use qmake, you say icon equals the app.icns. If you use another build system, try to fiddle it in. And the icon is automatically added to your bundle. So you don't have to worry anything. If you type make, then this icon will be copied into your bundle and will be added to the property list. So when macOS 10 sees that application bundle, it will actually display the right icon. So instead of showing the subfolder directory, it will show the right icon. And your application will look gorgeous on macOS. Okay, so macOS, we had the universal stuff, we had the icon, we had the application bundle. Now let's take a look at GNU Linux. Who deploys to Linux in the audience? Ooh, excellent, over a third. That's good. Who thinks it's a hassle to deploy on Linux? Okay, a lot. Good. Well, personally, I think it's quite a hassle if you look at the usual Linux distribution or at you have a third-party application and they have a Linux distribution out there. They either have 15 different packages, one for Red Hat, one for SUSE, one for Mandriva, one for this, one for that, or they just use a statically linked binary, which is huge and doesn't integrate well with your application, with your distribution, and sometimes crashes because they use an older libc, or you need to install some compatibility layers. So there's some mismatch, you cannot install it because RPM complains that there's some dependency unresolved because the different distribution name the package in different ways, and it's not very nice. So as I mentioned, you have a lot of Linux distributions out there, and usually you want to target at least the top 5 or so, because there is no clear winner out there. Ubuntu is very popular. A lot of people use Fedora or Red Hat. SUSE is quite popular in Europe. You have multiple architecture. Linux runs on my PowerPC. Mac runs on S390, runs on an ARM, runs on wherever. And you have multiple desktops and windowing systems. So how do we overcome? Yeah, of course, the multiple desktops. If you want to tie your application icon to it, there are multiple ways the multiple Windows system behave differently. How do we do that? The big answer is the Linux standard base. The Linux standard base is your savior. It defines a consistent ABI, not an API, not an abstract programming interface, but an abstract binary interface for Linux for 7 architectures. The LSB is basically a subgroup of the free standard group, or a standard of the free standard group. And in the free standard group, this is backed by IBM, Hewlett-Packard, HP, Intel, and a few other major players. So it has quite a good industry backing, and it also has a good backing from the distributors. So you can be quite sure that most of the modern Linux distributions are LSB certified, and this will work. Good news for us is Qt 3.3 is part of the LSB standard. So if any distribution that wants to be LSB compliant, which currently is most distributions out there on the market, has to ship Qt 3.3 in its default installation. And Qt 4.1 is a module. That means that it doesn't have to be installed in the default installation, but if there's a package or if there's an LSB Qt 4 package, it will follow the ABI standard. And most distributions, or basically all distributions that are LSB compliant, also have an LSB Qt 4 add-on package. So you can be pretty sure that your application will work. It might not be installed by default. The users will have to do an additional installation step, install Qt 4.1, because it was quite new when the Linux standard base, when the standard was created. But then your application will just work without hassle. How do we use the LSB? We install the SDK from linuxbase.org. Excuse me? I have a power supply. Yeah. Okay, so you install the SDK from linuxbase.org. You add opt/lsb/bin to your path. If you have a Qt 4 application, you set lsb_modules to Qt 4. And that's it. You run qmake and make. Now, for the 1/3 of you who does not use qmake, all you need to do is to tell your build system to use the lsbcc and the lsbc++ compilers instead of GCC and G++. Those two guys are really just wrappers around GCC and G++. All they do is to change your include paths and change your default library search paths to use the LSB versions of the libraries to link with instead of your operating system libraries. So you can be sure if something links within the LSB environment with LSBC++ and LSBCC, it will work on all LSB compliant distributions. And of course, all libraries that are not standardized within the LSB are statically linked, because you cannot rely whether that third-party library either will exist or which package name it has or which version is on that system, which ABI version, and so on. So you just link it statically. So you got the LSB compliant binary, but hey, where do I install them? The file hierarchy standard standardizes the Unix file system. You can read the specification under pathname.com/FHS. I'm not giving you the whole story here, just the gist of it. Basically, /opt is reserved for add-on applications, which I suppose that most of you are creating. So you can either choose to install into /opt/any package name or /opt/provider, which is usually a company name. So when we distribute things, we install into /opt/joltec.com/something. And provider must be an LANANA registered name, www.falafel.org. And basically, you just send one guy a mail, and he will add you to that list, and then this name will belong to you. So whenever you install to opt your directory, you can be sure that there won't be any clashes, that no one else will overwrite your binary. There are some disadvantages. The LSB defines an ABI, but not functionality. So you can be sure that all those symbols will be there, but whether it crashes when you call them or not, you don't know. But usually, since there's only one implementation of Qt, which is our Qt, you can be quite sure that it will work. And not all areas of application development are standardized. For example, sound or multimedia. ALSA, for example, is not in there. So if you want to show something, there's no standard. Even printing, cups, for example, is not standardized. So the good thing is that we can use cups, but you can't, because we are usually installed by the distribution, and what Qt is linked to internally doesn't matter. But the ABI makes sure what your applications can use, and you don't know, which ABI version of cups is actually installed. So you can interface with cups, but we can. So if you use QPrinter, you can print, but you can never write any software that has to interface with cups directly. This will be fixed in further versions of the LSB. The LSB is an ongoing project. They add more stuff. So, for example, ALSA or cups are on the roadmap and will be added later, and Xrender and all the other stuff. Also, the functionality provided at runtime is not really clearly defined, so you cannot be sure which image plugins are installed. You don't know whether you have GIF support, whether you have JPEG support. Of course, you can query at runtime, but you cannot say, I want to use a JPEG image. It should work on all the distributions. You don't know. Same with SQL drivers. Usually, all the drivers that are possible are installed, so I don't think that any distribution is shipping a stripped-down Qt 4.1, which doesn't contain all the SQL drivers. But you cannot be 100% sure. If that's not good enough, hey, deploy your own Qt library. You configure Qt with --prefix opt the app, and you use the following layout. You install opt the app in your application, then opt the app lib is your library, core, and GUI, and opt the app plugins contains all your plugins. The good thing here is if you configure Qt with the --prefix opt the app, that Qt uses a little trick called, or qmake uses a little trick called rpath. Again, if you use a different build system, you have to tell it to actually set the rpath in your application. What does that do? That basically overrides the library search path. So you can be quite sure that opt the app lib is not in the default system's library search path. No default system will look into that thing, but if you set the rpath in your executable, it will be actually hardwired to that location. So if the operating system cannot find the library in its default search paths, it will look in the rpath, will find your Qt library, and will work. Of course, if you do this, you're again pretty much limited to the least common denominator of all Linux distributions. So if you deploy your own Qt library, you have to make a decision which kind of X server do I require, which kind of external plugins do I require, which kinds of libraries. Okay, let's look at the other Unixes. Proprietary Unixes. Yes, it's quite a hassle. Okay, I was of course corrected. It's not only proprietary Unixes, it's also other free Unixes that are not Linux, like FreeBSD. I hope I didn't insult anyone. So FreeBSD and the other BSDs, the free Unixes and the proprietary Unixes, how do you do that? Usually make sure that you have all the SDKs installed and make sure that they fit to your library versions, otherwise you get mismatching symbols and you will get interesting crashes. And the safest way to deploy is just to ship a.tar.gz. I know that every operating system has their own package system, but once I start reading it, I get a headache and I just ship a.tar.gz. Unless, of course, you have a Unix guru in your company who does it for you. And what we suggest is you just write a small shell script to set the LD library path. And if you look at the Qt documentation at the deployment guide, we have exactly that little shell script. So the user just untars the tar.gz, launches that shell script that will figure out, okay, what is my current working directory, how is my binary relative to the current working directory, set the LD library path, your Qt libraries will be found, and it will just work. Yeah, of course, when you are packaging, when you create this tar.gz, you have to be careful, because on Linux Solaris IRIX, you get a file called libqtcore.so. On HP-UX, it's called .sl for shared library. On AIX, it's called .a, no matter whether it's shared or static. They always call their libraries .a. And on macOS 10, okay, you use bundles, but if you choose to do something manually, you have to be careful because they are called dylib. So the typical Qt application on non-Linux or non-macOS 10 Unix, you have the app, which is the executable. You have libqtcore with whatever suffix, so or sl, libqt-GUI. You have the app.sh, which is our small shell script, which your users will execute. And then, again, you have the plugins in the same directory as your binary, so they will be found. And everything will magically work, hopefully. Okay, I have 3 more slides and 8 more minutes. One common thing is if you have a lot of plugins, then on some operating systems, this can quite slow down your library loading. Because on some platforms, just DL opening a plugin to see what is in there or DL opening something is very, very slow. So what we do is we group plugins in separate subdirectories. If you look at the Qt plugins, they are already in separate subdirectories. And those are always relative to the plugin subdirectory. So if I showed you /plugins /myplugin.so, the same goes for the plugins. You say /plugins /image formats and then something. So all image formats are in plugins /image formats. All SQL drivers have their own subdirectory. All codecs, all accessible plugins, all input methods are in a separate subdirectory so that opening and resolving it is a lot faster. Then some GCC tweaks. The symbol visibility. Most other operating systems use it. With GCC larger than 3.4, or actually larger than 4.0 because there, so it really works. You can pass. You can reduce the symbol visibility for applications. Because by default, there's this little hack called LD preload, so people can load a library which can replace a symbol within your application and can do evil things. Usually you don't want to support that or you don't support that, so you just tell qmake to use switch on the symbol visibility. And what happens is that if you have Qt-based libraries, your libraries will be smaller. You get smaller symbol tables, smaller binaries. They will load faster. They will resolve faster. The only disadvantage is you have to make sure you use the Q export macros everywhere, just like Qt does. When you see a Qt class, it usually says class Q _ something _ export, and then the class name. To make sure this is a class I actually want to have accessible to everyone else, and every other class will be just ignored. So the compiler will just inline it or do all kinds of optimizations, or just remove the code at all if it's not used. Then you can use the -combine. Actually, the Intel compiler does it already. GCC, they just added it. Unfortunately, only for C. They work on it for C++. What does that mean? It does intermodule analysis. So you get even smaller binaries, meaning that usually what happens, you compile files. You compile one CPP file, another CPP file, another CPP file. You get a bunch of, let's say, 30.0 files, and the linker links them together. What the combine does, it does extra steps, so it basically does a small pre-compilation of all the files, and then in the linking step will optimize. So instead of optimizing every object file individually and then let the linker try to remove some bad code, the compiler, who has all the information necessary, will do the optimization. So you get even more optimized binaries. And if you configure Qt with -no exceptions, if you don't use exceptions in your code, you can save a few hundred kilobyte in binary sizes. Because all the exception handling code isn't there, you have a lot less symbols. So again, faster library, faster load times. This is just for completion if you want to cross-compile, or what I suggest for people who want to deploy on Linux. You just get a Linux box, an x86, an AMD 64 library, or an Intel with the, what do they call it, with the Intel 64 editions, not an Itanium, but actually a 64-bit CPU. Install a normal Ubuntu or whatever you like. And you'll get a compiler that can provide both 64-bit binaries and can create i386-based binaries. So you have this one deployment machine somewhere in your corner, and you have two Qt versions on there. One you configure with -platform Linux G++32 to force it to actually create a 32-bit installation of Qt, and another one which you just compile normally, so you get a 64-bit Qt. So on one machine you can create two sets of binaries, one for AMD 64 and one for 32-bit. And currently I would say these are the platforms you should support, because a lot of people have only 64-bit Unix installations, or Linux installations, so it's quite nice if you do it. If you want to be really nice, you can also support Linux PPC, which I'm using, but I've given up hope now that Apple dumped PPC. Okay, so much for my last slide. I hope I didn't rush things near the end too much. We have, I believe, 10 minutes for questions. And I'll be also here all time. You can ask